Okay, this is Automation Systems Technologies class, final project, spring 2013. Our assignment was to make this Fanuc robot do something, and we started out and we had a trainer box and a conveyor system. We had to reconfigure the conveyor system, and originally it just had the main conveyor, two conveyors on the top that sorted boxes through some gates. Right now we just have two conveyors with basically the main conveyor that supplies the good parts, a reject conveyor, and then that goes back to the end of the line. And we opened up the protective enclosure so that we could have access to it, and we've turned this into a tic-tac-toe playing robot. The goal is we have a vision system on top. You can see the camera on the top of the robot cell, and it's pointed at the window. Normally that camera would be pointed at the work surface where the robot is, but we decided to use it as an input device rather than a quality or a naming device for the robot. And so we have a tic-tac-toe board up on the window, and what that'll allow people to do would be to take these little targets, put them up on the piece on the window, and then the robot will register as an input. So I've programmed this entire robot. The robot was programmed using the Fanuc robotic logic. We've got a little hand teach pendant here. You can see the program running right now. It's basically scanning the picture on the screen that it can see, looking for parts. They're looking for that little puck to indicate where the person's turn might be, so it's just running through that routine. It's kind of a goofy little system for programming the robot. You have to do it all on this little teach pendant, so typing it in can be a little bit of a chore. That's the actual robot controller box right there. It's running right now. Its run light is on. There's the E-stop button right there for emergency stop. It's got a little air compressor here that supplies the air pressure to the actuator. You can see it's got air outputs there that go and control the little actuator tool on the gripper. So this is the game board that we made. Basically just tape up on the door with some little hooks, and that's where the parts go. So when we have an X or an O part, we basically just cut some plexiglass, put some holes so that they can rotate in any direction, and then we've got the standard block on the back that the gripper can engage with, and it puts the part on the hook. Now, this entire system has been programmed in RSLogix 5000. We've got control panel down here. If you open it up, we've got a CompactLogix L32E industrial processor. We've got an Ethernet switch there, the power supply for the processor. We've got our I/O modules here. We've got some digital input and relay outputs. The communication between the robot and the PLC is through some high-density cables. You can see them go into the box here. Each one of these has 50 conductors in them. We had to identify each one of those by hand. We're only using about a dozen of them, and they're going into either the relay inputs or the relay outputs or the digital inputs, and we have them wired up in here. We've got two motor starters. Well, we've got one motor starter here. That's for the lower conveyor that controls that conveyor. And then we basically have a solid-state switch that controls the smaller conveyor on the top. And there's our power supply, providing 24 volts to the digital inputs and outputs, and our wiring blocks on the bottom. So that was a lot of fun to rewire and make it all work. conveyor itself, pretty straightforward. Parts go down. We have a little plastic guide block. The parts go past a inductive capacitor, inductive proximity switch that is able to detect whether it's an X or an O. You'll notice that on the back of the X's we have a little metal screw, whereas on the back of the O's we don't. So this detects the metal part, and if it passes underneath there, it then knows that the part at the end is a X. And then at the end of the conveyor we have a through beam. This basically is sending an infrared signal, and when this part is in the way, it breaks the signal, and in this case the conveyor is telling it to move when there's no part there. And then we just put a little piece of plexiglass in the back here as sort of an end stop. The display we have here is a Maple Systems display. It's basically programmed to play tic-tac-toe. It can play tic-tac-toe manually. Or with the robot engaged. That was fun. Yeah, we've got different modes. We can make it so that the human is X or the human is O. Basically just toggles the display. You can make the human go first or the robot go first. If the robot moves first, a lot of times it's going to choose the center square. You can make the robot perfect or infallible. It's got two modes, so in the infallible mode it makes some random decisions, but in the perfect mode you really can't beat it. You can only tie. Only have a cat's game. And we can engage the robot. It's got a diagnostics I/O menu here where it basically shows you the status of many different internal registers and the inputs and outputs to the robot. It shows the status of each box. When I select a box, it registers that the box is in use. Is the top, the bottom light there indicates whether the piece has been put on the board by the robot, but since the robot is engaged, that hasn't happened. And then the player is player 10, the robot is player 1, and so it determines which is an X or an O based on that. When the robot is engaged, it's going to send signals to the robot via these digital outputs here. So we'll just do a master reset here, turn the robot on. I programmed this entire setup in RSLogix 5000, ladder logic. So let's put it through its paces and play a game. Put it in the I/O window to see what it does. Right now, it always assumes when you start out that the first piece is bad because it doesn't know, but in this case, a bad piece is, since it's the human starting first, a bad piece is an O. And there happens to be an O there already, so that's fine. So when I select a piece, I'll select the center piece. It's going to automatically instruct the robot to reject that first piece. There's the rejection command. So the robot is going to move. And it takes the piece and puts it on the top of the conveyor and rejects it to the back of the pile. Now that it has an X in its spot, it's going to actually put that piece where I instructed it to, in the center. Now the robot has made its move, but it's not going to display the move until, and there was an X there, so it rejected it, but it's not going to display the move until it's got it on the board. So it's putting its move on the board in the lower left-hand square, and now it's appeared on the HMI. And now it's waiting for my turn. So I'll make another move.
Yeah, that's what I wanted the most, because I'm probably recognizing the
And there's an X in position already, so it should put that piece right on the board. Now it's the robot's turn, and there's an O in position. Okay, he just blocked me. Well, I am going to have to block him. And I think we're headed for a tie here, because he is going to block me. We decorated this thing with a little goofy eyeballs. Have a sign up here. Test your skills against the TicTacToe-bot, if you dare. It's pretty menacing looking. Okay, well, let's finish this game up. Can't win it at this point. Only 4 pieces left. Okay, only 1 move left. I guess we'll finish it off. Now, it doesn't say the game is over yet until the final piece is played. Okay, now that the game is over, it's going to start removing the pieces. And it's going to do it in the order that it was placed. I keep track of the moves that were made. And so it's going to move, just remove the centerpiece. And now we'll get it to watch it remove all the rest of them. And the nice thing about removing them in the order they were placed is that it makes the game go a little faster the next time, because all the pieces are already in the XO alternating order. Only 1 more piece and the game is ready to be reset and a new player. There we go. Oh, there's 1 more. I didn't see that one. Oh, it's all set. And waiting for the next game. Pretty exciting, huh?